Hello everybody. In this session we will discuss probability and how it applies to poker. First of all, what is probability? Probability is defined as the number of wanted outcomes or successes, okay, divided by the total number possible. Total number of possible outcomes. Let's call it that way. Okay, so that's the way probability is defined, and this can help a lot in many facets of life when you're predicting things happening, right? When you're predicting events and whether you should do this or that. So anyway, for poker, very similarly, we can find probabilities of things happening, of the little hands. Let's say 5 cards, so we're going to do 5 card, hands, and we're going to see, for example, what is a royal flush? How difficult is it to find such a thing, right? You'll see it's less than I believe it's less than 100th, much less actually than 100th of a percent. Imagine that. So anyway, let me show you how we would do this. First, let's discuss the hands. So let's say the possibilities, the outcomes can be 1, royal flush, right? That's what? That's a straight 10, jack, queen, king, ace, right? With this of the same suit, So that's actually a straight flush. It's called a royal flush specifically because it starts with a 10 going up. And then 2, we can have let's give some space here. Number 2, we can have the straight flush. And let's say straight flush, that's not royal. So in other words, we're going to not do the same thing twice. And this is basically also the same suit and straight, but we're just going to say not starting with a 10. So maybe like a 7, 8, 9, 10, jack of same suit. And there are 4 suits, right? There are the what? There are the hearts, right? The diamonds. So let's talk about that for a moment. Let's talk about how there are cards which are 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, right? King, queen, king, ace in order of superiority, and that's 13, right? There's 13 face cards, so numbers, right? 13 values, 13 numbers, and what is it? And then also we have 4 suits, which is let's say hearts. We'll have a diamonds possible. We'll have a spades, right? And we'll have also a clubs as possible. Okay, like something like that, a clover leaf. Let me kind of do that a little better. Okay. So that's the 4 suits, and so altogether we have this and that, giving us 52 total cards, right? 2 of each suit, 3 of each suit, and so on. And number of total possible outcomes, okay? We'll talk about that at the end, let's say. So let's do that right now. So let's discuss quickly how would you find the total number of possible outcomes. Let me give you a little insight into this, more than just saying the answer is 52, choose 3. Okay, so let's talk about that. Okay, let me explain one thing. Let's say I am taking, like I have 4 objects. Let's say 4 people. Person 1, person 2, person 3, person 4, okay? And then I want to just take 2 people, a group of 2. Group of 2 from 4. Let's say groups of 2 from 4 of these people. Okay? How many? What's the number of groups of, so that's like a question, let's say, and let me show you how you would do that. So first of all, think about it. P1 and P2, first person, second person, is the same as P2, P1, right? So what really is happening is, first of all, think about it. You have 4 people possible. Let's say P1, and then you have maybe P2, P3, P4, right? But so you can have, think about it, you can have P1, or the first one can be, let's look at this way. This is really tricky for people starting with combinatorics. So let me kind of give you a little insight. Okay, the first spot can be P1, or P2, or P3, or P4, right? Okay, now, the second spot, right, can be P2, or maybe it can be P1, P3, or maybe it can be P1, P4, right? It can't be anything else, starting, right? Okay. Then, let's say the third spot for just P1, P2 can be a P3, or it can be P1, P2, P4. And then, of course, the last one has to be either P4 there or the P3 here to the remaining. This can be P1, P2, P3, P2, or P1, P3, P4, and that's going to have to be P4. That's going to have to be P2. Now, what I mean have to be, you're multiplying by 1. If you think about it, this is 1, 2, 3, 4, right? So that's 4 times. Okay, now you can, for the 1, 2, 3, 4, you can have, let's do the square, 1, P2 there, P3 there, or P4 there, and that's what's, because it's 3 are left, 3. Okay, now we did, look, we did, let's do this kind of bubble like that. So that's a P3 or a P4, okay? So that's times 2 because you only had 2 left, and finally the other one has to be that 1 remaining. That's actually 4 times 3 times 2 times 1, that's 4 factorial, okay? Remember that, 4 factorial. So that's 4 factorial, all right, and we'll talk about that later. So this is how many we're going to have if I'm doing the order matters, with order mattering. It's going to be 4 factorial, okay? Still no repetition, right? We're not repeating people. It's one person, one time. Like, you can't just use person 1 twice. There's only one of that person. So no repetition, no repeat. And so you will see there will be 4 times 3 times 2 times 1, 24 of these. You can actually see there will be 6 in each of these columns, columns, yes. P1, P4, and then P2, P3, or P1, P4, and P3, P2. And so similarly, you'll have another, you have 6 here, you'll have 6 there, and 6 and 6, and you will get the 24. It's very interesting, right? You see that, maybe. Hopefully you see a little bit of that. And so let me make it a little smaller here so we can kind of, well, we're good here. So let's see, that's that. Now you may wonder, well, okay, well, where's the choosing anything? Why am I ever talking about choose? Anyone ever hear of choosing 4 from 2? This is not the answer. It's not 24 possible such groups. Also, think about it. If I'm choosing 2 people from 4, this is 4 factorial is just how many 4 people orders there are, right? Okay. Now, why would I want to divide by 2 factorial? I want to get rid of this. Why? Because I'm talking about only 4 and 3. I'm only talking about the 2 people. I'm not talking about 1, 2, 3, 4 people. Okay? So I'm talking about really, is it P1 and P2? You see, this is why we divide by 2 factorial one time to get just 4, 3. In other words, but since 2 people, so one second, let me show you this. But also divide by the 4 minus 2 factorial, since we only need, okay, 2 people to need 2 people, not all 4, okay? And so that's that, okay? And you may wonder, what else is there to divide by? 4 minus 2 factorial, let me explain that, because we're not talking about the others. We get rid of the others. If that makes sense? Okay? So if I'm choosing 3 from 4, I'll get rid of that 1 that I don't need, if that makes some sense, right? So it'll be 4 times 3 times 2. So really, so far, we are 4 factorial over 2 factorial, okay? Let me lower everything else here for a second here. This is kind of important to lower this, okay? So you can see what in the world is actually going on when people say 4 choose something. It's or you know, like we're going to do 52 choose 5. Well, why, right? So let me show you. We have 4 factorial over 2 factorial. Where is, well, actually, let's call it, for now, 4 factorial over and 4 minus a 2 factorial. Same thing, of course, 2 factorial. But what about the other? There's another 2 missing, right? Remember that, anyone? That that's going to be what choose. If you say 4 choose 2, that equals to this. Let me kind of show you a little bit different with the red. The other thing is, what about the order? Order doesn't matter, right? And order, what order, how many orders are there of 2 people or n people? It's n factorial. So m people is m factorial. So really, we're divide by another, right? 2 factorial, because think about it, everything that was, it's a little more different in the higher number of cases. Like let's say if you do 5 choose 3, maybe another example to demonstrate. But what would happen is we would put another 2 factorial here, because that order, we have to get rid of that, because think about it, P2, P3 is the same thing as P3, P2. If we talk 3 people, let's say P1, P2, P3, well, there are actually 3 factorial of those different orders that we have to just talk about one of them. So we would divide by n factorial. In other words, actually, if you do n, choose m, so m objects from n, it will always be n factorial over m factorial and n minus m factorial. Cool, right? That's an interesting formula that maybe some of you felt out as I was explaining. Okay, it's a very difficult thing to sometimes teach or to grasp. I think myself, it just took me time to understand it over time. I never was taught it in an easy fashion. I would wish I could see something like this, you know, back in the days. Anyway, now, so what are our total possibilities? Let's think about that. What are the total possibilities for getting just 5 cards from 52, right? That's basically, we're selecting not 5 people, but 5 cards. They're all different 5 cards. And so the number, okay, the number will equal to 52, to choose 5 from 52, that's going to be 52 times 53, 1 times 50 times 49 times 48 times 47 times 46, and so on, all over, okay? 5 factorial, 5 times 4 times 3 times 2 times 1. You'll see a lot of numbers cancel. Times what is 52 minus 5? 7, 46, 44, so on. Okay? Cancels. See this right here? This with is the same thing. That go away. And then if we divide, okay, what is 4, 3, 2? That's a 24. 48 has 2 of those. And so we have this. If you multiply this, what we get, you know what we get? Let me see. It's 52 times a 20. That's 10240. And then 51 is 49. The trick is you can do 50 squared minus 1 squared, right? Times 2499. And you know what that is? That's 2500. Let's even keep it as 2500 minus a 1. Cool, right? And then what is that? We can actually multiply numbers, right? 1,000 of that is 2,500,000, right? And then we're going to subtract the 1040 from also the 40 of those. So you have a 100,000 minus 40. That's going to be 999,000. No, 800, right? 899,960. So that's what we're going to also add, because we had 40 that I didn't do of the 2500s. And if we do that, and actually that's a, I believe that is actually not 900,000, but I mean not what is it, 100,000, but only 100,000. So now we're gonna have 99,000 left, right? Take away 100,000 minus 40, and if we add all this up, we get 2. What is it? 1 second. Let's make sure we're careful here. 999. Oh, we took away another 1040. So this actually should be 98, right? There's another 1,000 taken away, and so that was that. And so we have 2,598,960 total number of possible outcomes. 52 choose 5. That's a lot. If you get a hand of 5, and we're already taken out of order and everything, you still have, you know, these many possibilities, 2.5 and actually more possibilities of cards. So you probably never experienced all of these, right? For example, somebody says, "Oh, I have a royal flush." That's once in a lifetime experience for somebody who plays poker a lot. Okay, so just so you know. All right, so let's do this. Let's calculate these numbers. Okay, let's calculate these. So, a royal flush. Ready? Let's do royal flush. How many royal flushes are there? Where it has to be 10, Jack, Queen, King, Ace, and it's of the same suit. There are 4 suits. There are 4. Ta-da. Okay. And then, of course, the probability will be 4 over that big number, 2,500,000, etc. Straight flush. there will be, it starts with a 2, a 3, a 4. Basically, it can be any straight flush, but not a royal flush. So it's going to have to be 8, not 9 starting numbers, because the numbers are 2, 3, 4, 5, 6, 7, 8, 9, 10. But forget the 10. We're going to start with a 9. So the highest will be 9, 10, Jack, Queen, King. Forget the 10, Jack, Queen, King, Ace for the royal flush. So we'll have the 36 minus 4, the 32 left. So what is that? 8 times 4, still 4 suits, 32. Okay, that's 32 there. Let's call this N2. Let's call this N1. Okay. Let's talk about 3. The possibility 3, that will be what? The next thing is actually 4 of a kind. Okay, 4 of a kind, that's tough to get, seems, right? But you'll see it's a lot more common to have 4 of a kind than a straight flush. 4 of a kind, what we do is we say, okay, that's N3. That's going to be, okay, we pick one card to be that 4 of a kind. Let's say Queen, 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 Queen. Let me actually put a demonstration. Let's say Queen, 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 Queen. Of course, they're going to have all 4 suits used up, and then maybe a 7, right, of any suit. Okay, so what I'm going to do here, this is the way I'm thinking. Let's do one card and then 13 of those, Queen or whatever, 2 or Ace, 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 right? And then that's it. Suits all going to be used up. The other cards, how many are left? You have 48 of any card to choose from left. You can't use a Queen anymore, basically. And that's going to be, what is that? That's 50 times 13, so that's, what is that? That's 650 minus 26, 624 I'm getting, okay? 624, okay? Okay, so that's that, interesting. Okay, number 4, let's try number 4. And I'm really trying to do computational, like, without too much of this calculator nonsense, okay? So I'm teaching you, like, try to really flow with the computation, the numbers, the adding, subtracting in your head or writing out. It's very helpful, not just in mathematics, but in the overall scheme of academia. I really strongly encourage my students to be good with numbers. Okay, that's a strength, I believe. So 4 of a kind, the next thing is going to be a full house or boat, some people say. Okay, and so a full house is when you have, let's say you have a same thing, Queen, 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 but now you have only 3 of a kind and you have a pair. Let's say you have a 9, 9, okay? So what I'm going to do here is, and this is a little tricky because think about it. We already understand that a queen and a 9 is not the same thing as 9 and 9, queen, queen. They're different. So we're not going to have to divide by any 2 because we're not really abusing that order a few times. In other words, queen, how many times to get that? Well, that's a 13, 13 types of numbers, right? Queen is one of them. And then the suits, you're going to choose 3 from 4. Really, it's also like choosing 1 not being there from 4. And that's the same number, 4. This is actually 4, okay? For example, what suit's not there? So maybe a heart is not there. In other words, you have a spade, a club, and a diamond for queens. And the 9, it's a 12, right? The other 12 cards of the numbers remaining. And the suits can be, you choose 2 from the 4 possibilities. 2 suits from 4 suits, right? That's kind of tricky because you have to have, they have to be different. And so this is going to be, we're being careful. You don't want to mess up anything, right? Because you can always overcount. And we'll have a checking point at the very end to see are we really correct. So what is this? That's 156 is 13 times 12. And then that's a 4 and a 6. That's 24. Let's actually just multiply these numbers. Okay, 24. Let me have some fun with this. It's 25 minus 1, right? Okay. And what's 156? That's if 4 goes in there, or no? 4 goes in there, right? It's actually a 14 and 25. So that's a 39 times 4. So 39 times 4. So it's going to be 3. If I multiply these, think about it. 39 times 4 times 25 is 3900 minus a 156. Cool, right? I'm just messing around a little bit here. And you get a 4 left and another 4 left, and then a 7 and a 3. 3,744 is what I'm getting. Hopefully that's correct. So that's N4. Okay, let me kind of make a little neat here. N4 is equal to this. Okay, so we have N1, N2, N3, N4. We did some combinations already. This is, you see, it's not easy. It's getting tougher. And by the way, quick comment. What do you see here? You probably see that, look, hopefully you notice, 4 of a kind, 624 ways versus a straight flush, well, like even the royal flush, straight flush combined, 36. That is so much smaller to get a flush, a straight flush, or royal flush than it is to get a 4 of a kind. And we never think of it that way. We're thinking, well, wow, ace, 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 almost impossible. Talk about impossible. You're talking about royal flush is impossible, right? That's just another way to think about some things. But you have this mindset of, have this understanding of, the largest and smallest of numbers, basically. Very big. Okay, number 5, and this actually improves your poker game if you ever play. I'm not a big, poker player per se, but I played in the past a little bit. And, there are cash games, there are tournaments, and they're very different game styles. But I remember one asset for me was the probabilities. I understood those rather well compared to some other players, let's say. Anyway, full house. And then what else is there? There's a flush that's possible. Flush is all... And by the way, if we get, let's say I said flush and then straight, or I said straight first and then flush, you would see the straight has more possibilities. So actually it's less strong, it's less prevalent than the flush. Flush beats the straight because it's less likely to happen, basically. Okay, so flush, that's going to be, look, think about this. You have any numbers, like let's say 10, let's keep them kind of in order. So 8, 10, jack, king, and ace, for example. There have to be 4 different kinds of cards and any suits for each of those. Besides, we cannot have a straight flush, right? So flush but not straight. And that's going to be, look, that's going to be n5 is equal to, so to be flush, first of all, we have to get 13 choose 5. We have to have 5 different values of the, right, the numbers, like for each of the cards. It cannot be a pair. It cannot be anything like that, because the suit's going to be the same suit. You can't have 2 hearts and a 2 hearts, right? That's not going to happen. You only have one of those cards. So 13 choose 5, and then you can do, hey, I'm going to do times 4 to the 5th power, right? But you know what? We're going to take away that 36, that straight or royal flush. Or you could even do this right here. Let me show you another trick. You could say it's 4 to the 5th minus that 1 chance, the 4 chances that you have all of the same, you have the same, what is it? The same suit, right? Because if all of them are the same, well, that's all the same suit, but if you have, what is it, you can't have the straight. Oh, this is going for straight. No, 1 second. This is good. So, and then take away the 36, right? Because you cannot have a straight flush. So this is correct. Take away 36. I don't want to confuse us there. And so that's going to equal to, let's see, what is that? I'm going to do this. Let's see, 13 times 12 times 11 times 10 times 9 over the 120. 5 factorial is 120. So 12 and 10 go away. Okay. Bump, bump. And so you actually have 99 times 13. That's 100 times 13. That's 1300 minus a 1 at 13, right? And then also minus a 36. So let me kind of do that. That's a 1287 minus 36. 1287 minus 36. 1287 minus 36. 1251, which is not correct. Okay, let's see. So 3, 6. Is that correct? Could be, but I'm surprised there's a 1 there for 1251. And it has to be smaller, by the way. Oh, that's a... I forgot to multiply completely by 1024. So that's, of course, that's an issue here. Times that 1024 for 4 to the 5th power. Minus a 36 at the end. So let's do this. What did I say? That was a 13 times 11, 143 times 9. Let's just do this. 99 times 13, 1,300, 1,287 times a 1024, right? And minus 36 at the end there. What is this going to be? Let's see. That's going to be a million, right? Okay, 1 second. What am I doing? This flush is just 4 of these, right? Not to the 5th anything. You have 4 possibilities. So that should be that. Okay. Wow. So that's just a 4 there. So you see, we're doing our best. Like, this is what you would do. I make mistakes along the way. I'll fix them, but I'm not going to do something where I'm going to prepare this lecture ahead of time. We're gonna run it together. Make mistakes, we'll fix them. That's how we're going to do it, all right? All right, so anyway, not too much at least. Obviously, I've done this before, but okay, so let's try this, and we're multiplying by 4 now, and take away 36, okay? And that's just going to, let's just multiply this out, 8, and then that's a 34, so that's a 1, and then, what is that? That's a 5. 5148, okay, let's see, yeah, that's correct, and then minus a 36. 5112 is what I'm getting. Hopefully that's how many types of flushes there are that are not straight flushes. or royal, right? So that's that one, number 5. Number 6, it's a straight, right? To get a straight, what do? That's something where you would start with the numbers. You can be a 10 all you want, as long as it's not a straight flush. So we're going to have n6 is equal to, we're going to choose 9 cards to start with, right? What is that? A 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, or a 10. That's 9 cards, right? If you think about it, 10 minus 2, and add the 1 because it's inclusive, is actually 8 plus 1 is 9. So you start with, you have a starting card. Let's say you have an 8 starting, and then you have, of course, have 9, 10, 11, Jack and Queen, right? This is how a straight works. You have the lowest of those. So that's what I'm considering. And you see, I'm trying to minimize the way we have to do all these combinations from all kinds of sides and angles. It's a trick. I'm separating a little bit of the, let's say, the faces, the face values, the numbers, and I'm separating that from the suits. And anyway, this is the number, the initial number. And then that's already a straight. Now look, we have how many possible faces for each one? That's 4 to the 5th, right? Suits, for each card you have 4 suits for each one, and take away 4, and you see that's going to be minus a 36 actually. Take away 4 from just being of the same, right, all hearts, all diamonds, all spades, all clubs. So that's that, and that's going to equal to 1024. So that's 9 times 1020. We can do this quickly in our head. It's going to be what? 1818, what is that? 0, right? And that's actually not correct. It's 118, no, 1, what is that? Let me try it one more time. Wow, so 9918, right? Yeah, 0, 9,180. So that's that. Okay, so that's what we have for straight. Okay, cool. Let's go on to, that's how many straights. That's a lot of straights possible, but guess what? It's still very difficult to get even a straight. The next thing will be a 2 pair. Okay, 2 pair would be what? That would be, let's say you have a 7-7, and then a Jack-Jack, and then maybe a 5. Okay, so you have to have, look, here's what we're going to do here. Ready? We're going to say kind of carefully, we're going to say, this is a little easy to mess up on this one. We're going to say for the 7, how many there are? 13 types of cards, right, as far as the numbers, the values. And so that's 7, that's getting a 7 or whatever number. And then we're going to have suits 4 choose 2, right? Two cards there, from 4 suits you choose 2. For the jacks, you're going to have a 12, and then also 4 choose 2, all right? And then 5, that's just 44 cards remaining, right? You can't have 7, 7, 7, 7. You can't have Jack, 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 Jack. Take away 8 from 52. That's one way to do that. You have 44. Or you can do 11 times the 4. The suit is 4. 4 suits possible. You have, what is this? 156 times, that's a 36. This is a 6, and this is a 6. Times a 44. That's 40 squared minus a 4 squared. So let's say times 40 squared minus 16. Okay, that's 15. That's actually, you know what that is? That's 16. That's 160 minus 4 times a 1600 minus a 16. Let's see if we're getting anything out of this. Hopefully I'm not making too many mistakes. Okay. Let's see if I made any mistakes here. One second. One thing is we have to divide by 2. Notice that. The 7, 7, Jack, Jack. What if it's a Jack, Jack, 7, 7? Right? You have to be careful. So let's make sure that we understand that we have to divide also everything by 2. Very tricky. Careful there. So we're going to divide this by 2. And then actually that's going to be, make that easier. That's I was just going to do this because look, but that's all right. Let's just do the, what is that? 160, so it's 80 minus 2, so 78. Let's just do this directly. 1584. I'm going to multiply these numbers, right? And I'm going to get, what is this? 2, and we'll make a mistake. We'll go back and fix it. Let's see, 64. So that's a 67. So 40, 46, and then 8. So 12, 112, 1, 2, 6, 7, 2, the 0 here, and then 7 times. I'm a little bit off here, of course, as you see by the multiplication, but it's all right. Because what I can do is this. Usually we're used to this, right? A little bit on the number under that one. Put a 0 because it's 70 now. 28, 2 here. It's 7 times 8, 56, 58, 5, 0, 4 there, 7, 11, right? And we have 2, 5, and then that's a 5, and that's a 3, 2, 1. Feels like we're making some kind of mistake. 123, 5, 5, 2. That's too much. 2 pairs, there's not that many 2 pairs. All right, where are we messing up? Let's see. Straight, and then, oh, we didn't do 3 of a kind. Maybe there are that many 2 pairs. Let's see. Okay. We'll see. So that's a 2 pair, but you see we didn't do what? 3 of a kind. That's more difficult. You'll see why. So let's call this an 8. Okay. We'll check that one a little bit. So this is maybe, if it's off, well, we'll see. But I don't think so. I think maybe actually it is correct. We'll see. So 8 is 2 pair. Now you see we forgot something. What about a 3 of a kind? That's tough to get. So 7, and let's make this kind of uniform. Let's make it a little parentheses here. 8. Okay, so 7 is 3 of a kind. This is easier a little bit than the one we just did at the bottom. 3 of a kind. This is like 4 of a kind, but you only have, think about it like a queen, 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 and then 3 and 9. Okay, and so what the idea here is we have, okay, and 7 is equal to, for a queen you have 13 options, and then 4 choose 3 for the suits, right? 3 suits from the 4 times the 13 and 3 and 9. You know what we're doing? We're really just choosing 2 different cards. That's 12, choose 2. I could have done it kind of below a little bit, secretly with a, it's right here. You see this 13 and 12 and 2? That's a 13, choose 2, to be honest. So that's actually what we could have done for the 7 and Jack, or Jack and 7 idea. So anyway, 3 and 9 can be 12, choose 2. You have now 12 values left. Choose 2 from there, and then the suits can be anything. Yeah, times 4 squared. Yep. And that's going to equal to 13 times 4, 52 times a, what is that? 12, choose 2, that's 12 times 11, 66 times a 16. Okay, let's see, how do we quickly do this? Let's see any tricks. How about 50 plus 2 times, and this one is what? Let's do 66 times, so 660, all right, plus a, let's do 6 times that, 360, and plus a 36. Okay, let's look at some whatever we can do, right? And so that's a 50 plus 2 times a, you see that's a 900, that's a 1000. Of course, that's what? That's, you see that's actually, what is that? 1020, 1056, right? Is that what it is? Yeah, 920, so yeah, okay. And then we do that by 50. You know what that's going to be? That's going to be 50, what is that, 5,000? Is that 5,000 or 50,000? Wow, okay. Yeah, 50,000. And then, of course, we're also going to add, so 50 times that is 50,000. That's a 25. So 5 times that, let's do this. Let's do 5 times that for a second. So 5,230, add a 0, right? You see that? It's a 5230. 250, actually 280, right? Because 25 and a 30, 250 and a 30, and then a 0 added plus a 2 of those, 2112, right? And that's going to be equal to, that's going to be on 7. Hopefully that's correct. You see, it's easy to make a mistake here. 5, 4, 9, 1, 2. All right, hopefully that's right. We'll check this if we have to. Okay, so that's the case. And is it bigger, is it less, hopefully, than the next one, which it seems like it is, right? If it wasn't, then we were for sure would be in trouble. So let me see, what are we going to go to next? Well, if you think about it, right? If you think about it, the next thing is really just a 1 pair. Okay, so the next thing is 1 pair. Think about what would be with 1 pair. Well, with 1 pair, we would have, with 1 pair, well, I'm just really, you know what, I'm going to get a calculator, I'm going to check the 7, because I feel like we're kind of messing up here. 1 second. So this, 2. Actually, we're correct, I think. We'll see what happens. All right, so number 8 is that. Number, that's 2 pair. And number 9, that's a 1 pair. That's really the only other special option we have besides the high card, which is nothing really special. So 9, okay, that's the thing here. It's very similar. Think about what we did with number 8. Okay, so it's going to be like a pair, like let's say Jack, Jack. and then maybe a queen, a king, and a 3, right? So what this is, what's n9 about? The number of options to get n9. Well, that's going to be, okay, choose 13. For the one that has a pair, you have 13 cards, okay? And you're going to choose a suit. Okay, 4 of those for that. Oh, I mean, choose 2 suits from the 4. 4 choose 2, right? Then we're going to choose 3 remaining cards. I mean, a queen, 3 remaining values, right? That are not the same. So it's going to be 12, choose 3. And you have to do 4 cubed, right? For each one of those, you have any face spot you like. We're not going to have repeating faces because there's one pair. Jack hearts and Jack hearts is not possible. So this should be it. You see how quickly we did that now. We're getting a little bit more familiar with it. So it's 50, what is that? 6 times 13 is 78. Times a 12, that's a times a 10 times 11, that's a 2 times a 20, what is that? Times a 110, that's a 220, times a 64. And let me kind of, like I said, let's do this without any calculator. So that's a 78 times, let's just do this, 78 times 64. Let me show you how I would do this quickly. And then let's do that. That's a 4. I mean, there are other options like 80 minus 2, 65 minus 1, or 60 plus 4, whatever you like to do. Let me actually show you how you can do that. Let me show you I can multiply 78 times 64 rather quickly. So watch this. You could do this here with 80 minus 2, right? And then 60 plus 4. So that's going to be, of course, 4800 plus 320 minus a 120. So that's going to be plus a 200 minus 8, 192. 4992. You see, that's kind of cool, right? If it's correct, that's what it should be. And then times a 220, right? We didn't do that. And that one will be, let's just do that. It's a 0, and then 2 times that is it's almost like a, what is that, 10,000, but a little bit less by 16. So 9, what is that? 4840, right? Yeah, okay. And then 99840, 0, and so we have 0, 4, 2, 8, 9, 9. 998,240. It doesn't feel completely right, but okay. Feels like this should be bigger. What did we make a mistake on? Oh, this one should become a 10. Yeah, of course. 1 second. Yeah, this becomes a, so 1,098,240. Okay. That's almost the 2.5 million. So that's almost half of, the total possibilities, if you think about that. Well, that should be correct. We'll see. So, something like that. Let's see. Let's check that later if we have to. But let's do one more thing, is the no hand. Let's call this a star. Okay. Nothing. No, it's not special. Nothing special. And this is basically, what this is called? It's called a high card. So it sounds special, but nothing special about a high card. If you have an ace and some small stuff, actually that's not too bad compared to, you see that everything else is actually not that big neither. But high cards, so nothing special. Let's call this n star, okay? Equals, what is the chance of not getting any pair? Let's figure out, how do we do that? Let's say, how do we get a 3, a 5, a 7? We don't want a straight neither, right? A king and an ace, for example. All kinds of numbers. So we have to, you know what I'm going to do? I'm going to say, hey, let's choose 5 values that are different. Okay, that's what we're going to do. We're going to do that. So we're going to say it's equal to, let's move it a little bit here. Okay, let's do from 13 values, face values. We're going to choose 5, right? 3, 5, 7, king, ace. There's one example. The suits can be, hey, anything, right? Times 4 to the 5th power. But cannot have a straight, cannot have a flush, but if you can't subtract, and you cannot have a straight flush or a royal flush, right? So you cannot have the straight. By the way, remember, we already took away straight flush. Otherwise, we have to be careful and add it back. If we're subtracting a straight, if we subtract any flush, then we would have to add back the straight flush. But this time, since we have them already separate, right? They're all different. Like the straight is not the straight flush. We're going to take away the straight. So n straight. What is that? That was n. Let me actually just put these numbers in. So that was what? that was N6 and N5. We take away N6 and N5 because it could happen, right? That we have N6 or N5 for the way we did it. Minus N5, minus N6. That should be it, right? So as long as it's not a straight, it's not a flush, and they're all different number values, right? In other words, all face values that are different, you're going to have a nothing, no pair, nothing there. So this guarantees no pair, this guarantees no straight, no flush. And we're basically having nothing. It's kind of tricky, right, to do that quickly. And you have what? 13, remember, times 11 times 9. We already did that. It's 99 times, so that's 1,300 minus, so 1287, that one, times that's a 1,024, okay, minus what? Minus a little whatever that is, so 9180, 5112, 9180, 5112. I'm going to add these up and subtract them from the same thing. So this is going to be 1287000, right? And then a 24 of those. What's 24 times? Let's do 20 times this. It's a what is 20? Let's do a 0, and then 2 times that is 2574. 2574. You see that? That's what I'm doing. This 20 times this number, 2574. Is that 7? Yeah, that's 7, 4, and 4 times all that. That's double this one without the 0, right? That's a 5, 1, 480, I believe. 448. Let's see, is that correct? Seems like it. Okay. And if I add all these up, that's just that number. You see, I'm kind of trying to add these up quickly. That's going to be 8, 8. Hopefully this works out. Really easy to make a mistake there. 8. And then that's a 7. That's a 1. That's a 3. That's a 1. Okay. Feels kind of fishy here, to be honest. Probably made a mistake somewhere. Hopefully not. But let's see. You know, we'll see what happens. And so minus, what is this? Minus, so subtracting, oops. Subtracting, what is this? This is almost 15,000. It's 14,000, right? And then what are those numbers over there? 292. So take away 14,292. Okay. Hopefully that 888 is correct. Really seems kind of, you know, a little bit sneaky there. 6 here. Oh, that's subtraction, right? Yeah. So 6 there, and then that's a 9 left. That's a 5, and then that's a 3, a 0, 3, 1. So this is for getting nothing. All right. All right. So I'm feeling like I want to check this one. Let me get a calculator. 1 second. 13 times 11 times 9 times 1024. And take away 9180, 5112. I'm getting 1303596. Oh, cool. Okay, seems like that's correct. Okay, let me show you a few things. One is the big thing. Let's do some cool stuff here. Ready? So here's what we're gonna do. What is the sum? What is the sum of right here of those ni without the n star from I equals 1 to 9, right? What do we have? How many possibilities? 9, 9, right? So how pair or better? How many ways are there to get a pair better? Well, let's just add them all up, right? N1, N2, N3, and so on. And we're gonna have, if I add all these up, I'm just gonna do this with a calculator. 4 plus 32, 36. Well, I can do that. 624, so 660 plus a 3744. What is that? 4,404. Right, plus a 5112. Now I'm going to just calculator 9,000, and then 500. What is it? 16 plus a 9180 plus a 54912. Okay, so far we have 64,000 plus a 123 552. So far 187,000 something, and then plus a 1,098,240. Okay, I'm getting 1, 2, hopefully this is going to work out, 1,285,884, okay? Now, n star, remember, is equal to that number above, 1303596, okay? If you add these up, add them, the sum is equal to, let me add those up, 1303596. That's going to be, so let me show you, we're getting a 2, 5, 8, 9, 480, and so I'm a little upset, to be honest, but this is real, because somewhere, right, somewhere, it's not matching up with, I was going to be kind of fancy and say it's matching up with 25, that number 2598960. What is this? 259889. That's too small, right? So where am I missing something? Probably messed up by adding the numbers. 1 second. Did I add everything? Let's see. Plus a 9180. Okay, let me add up carefully one more time. 1, 2, 3, 5, 5, 2. It's easy to make a mistake here. Let me carefully just add them at least. Plus 1 pairs 1098,240, and then of course we'll check if we have to, if this is not working. 54912 plus 9180 plus 5112 plus 3744 plus 660. I'm getting 1295 this time. Yeah, this is 95, okay. 400. Whew, that's a little better. Kind of. Well, that's different though. 1 second. 1 second. Why is this different all of a sudden? Huh? So now I'm again getting a mixture of numbers. Let's see. 600, okay, let's do this carefully. 660 plus, you see, it's so difficult just to add numbers. 3744 plus 5112 plus 9180. I probably put a 22 there. Plus 54912 plus 123552 123552 plus 1,009,8,240. I'm getting 1,295,400. Okay, well that's what we're getting. So that's for some reason what we're getting. And then 400. Feels sneaky. Feels something's off. 1 second. A little bit off. So what did I not do? Did I take something away? If I add these up, let me quickly add these up. 1303596. It's a little bigger than I want. So let me show you. Now it's 2598996. Okay, 2598996. We want 25989. So 36 more somewhere. Okay, let's see where. You see how that's tricky there? How we didn't take. We have to take away. So look at this. The n star. Okay. Oh, we haven't talked about taking away the straight flushes and the. So that's n1 and n2. You see, n2 and n1. Yep. There we go. Another 36 subtracted. There. See how we find the mistakes quickly if we are careful. Minus 36. So this minus a 36, and this is going to be. Our number is 1,303,000. This is for what's this, just a no special, just a high card. 560. Okay. Cool, right? So this is now adding up to, if I put the right ones, this is 60 here. This is a gonna be a 60 there then. Okay. That's that. That's 560. So you see, it's not magical. We make mistakes. We try our best, but this is exactly equal to our n, the total number of outcomes, because the chance of having something is 100%, if you think about it that way. Let's quickly see one more thing of insight is, what is the probability of having just high card? Just high card. Just basically nothing special. Okay? Kind of call it just high card. That's going to be that 1 million, what is it? This n star over n. Okay? And let's do percent. Okay, so I'm going to divide this by, what is that? 1, 3, So what is that? 1303560 divided by the 52 choose 5, so 2598960. Guess what we're getting? 50. You know what's interesting? Let me show you. This is what's cool about it. 50.1. Let me say approximately. Okay, 50.16%. So you see a little above the 50%. Hence an amazing game, especially for the casino, that you're not going to have anything better than just a high card. All right, I hope this was entertaining. Okay, I really do, and there are so many other things you can look into this. For example, what's the chance of getting anything else? We have that. Just divide any of the circled numbers and n sub whatever. Divide that by the number of the total possibilities, the 2,500,198, and so on. Okay? All right. You have a great remainder of the day, everybody, and I hope you enjoyed the video.